For thousands of years, people have looked into the night sky searching for answers. Every generation has wondered how the universe began, how galaxies formed, and whether there is an underlying pattern connecting everything we see across space. As science advanced, our understanding of the cosmos grew. Telescopes revealed planets, distant stars, and enormous galaxies far beyond the Milky Way. Yet every major discovery seemed to create even more questions than it answered. Today, humanity possesses its most advanced space observatory ever built, the James Webb Space Telescope. Unlike previous telescopes that mainly observe visible light, Webb specializes in infrared light, allowing it to detect incredibly ancient objects whose light has traveled across the universe for billions of years before finally reaching its mirrors. Looking deeper into space also means looking farther back in time. Because light travels at a finite speed, every distant galaxy appears as it existed long ago. Some of the faintest objects Webb observes are seen only a few 100 million years after the Big Bang, giving astronomers an unprecedented opportunity to study the universe during its earliest stages. Before Webb, the Hubble Space Telescope transformed astronomy by revealing that what appeared to be empty patches of sky were actually filled with countless distant galaxies. Hubble demonstrated that the observable universe is unimaginably vast. But there was one major limitation. Many of the oldest galaxies had become invisible to Hubble because the expansion of the universe stretched their light beyond visible wavelengths into infrared radiation. This is exactly the challenge Webb was designed to solve. Almost immediately after beginning scientific operations, the telescope started uncovering galaxies that surprised researchers around the world. Instead of finding only tiny, irregular collections of stars, Webb detected galaxies that already appeared remarkably organized during the universe's youth. Some contained rotating disk-like structures. Others showed evidence of rapid star formation on a scale few scientists expected to see so early in cosmic history. These observations suggested that galaxies may have assembled much faster than many theoretical models predicted. Even more intriguing was the chemical composition of these ancient systems. Astronomers identified elements such as carbon, oxygen, and nitrogen inside galaxies that existed surprisingly soon after the Big Bang. These heavier elements cannot be created during the birth of the universe itself. They are forged inside stars over millions of years and released into space when those stars reach the ends of their lives. Finding these elements in extremely ancient galaxies indicates that multiple generations of stars had already formed, evolved, and enriched their surroundings far earlier than expected. This paints a picture of an energetic young universe where stars ignited rapidly, evolved quickly, and reshaped their environments in a relatively short period of cosmic time. As researchers continued analyzing Webb's observations, another mystery began to emerge. Hidden among the earliest galaxies were enormous black holes. These objects contain millions or even billions of times the mass of our Sun, yet some appear to have existed when the universe was still remarkably young. According to current theories, black holes normally grow over long periods by absorbing surrounding gas, dust, and occasionally merging with other black holes. That gradual process should require hundreds of millions, or even billions, of years. Yet Webb has revealed candidates that appear to have reached extraordinary sizes much earlier than expected. This discovery has sparked intense scientific debate. Some astronomers propose that massive clouds of gas may have collapsed directly into black holes without first becoming stars. Others believe conditions in the early universe may have accelerated black hole growth in ways that existing models do not fully describe. Whatever the explanation, these discoveries suggest that the first chapters of cosmic history were far more dynamic than scientists once imagined. Rather than developing slowly and quietly, the young universe may have experienced an extraordinary period of rapid construction, producing galaxies, stars, and giant black holes at an astonishing pace. And these remarkable discoveries are only the beginning. As Webb continues to peer deeper into the cosmos, astronomers are beginning to uncover something even larger than individual galaxies, a gigantic framework stretching across billions of light-years that appears to organize the universe itself. That hidden architecture will become the focus of the next chapter. The enormous framework astronomers are studying is known as the cosmic web, a vast network of invisible dark matter, hot gas, and billions of galaxies linked together across unimaginable distances. At first glance, the universe appears random. Galaxies seem scattered throughout space without any obvious order. But when scientists map the positions of millions of galaxies, an extraordinary pattern begins to emerge. Instead of being evenly distributed, galaxies gather along gigantic filaments that stretch across billions of light-years. Between these filaments lie immense cosmic voids, regions containing very few galaxies at all. Together, these filaments and voids form a breathtaking structure that resembles an enormous three-dimensional web spanning the observable universe. Although Webb cannot directly see dark matter, its observations help astronomers understand how this invisible material influences everything around it. Dark matter does not emit light, reflect light, or absorb light. Yet its gravity shapes the movement of galaxies and provides the invisible framework upon which ordinary matter gathers. Scientists estimate that most of the universe's matter exists in this unseen form, making it one of modern physics' greatest mysteries. As Webb explores increasingly distant galaxies, researchers are finding evidence that this cosmic framework may have begun forming surprisingly early in the universe's history. If confirmed, these observations suggest that gravity organized matter much faster than many previous computer simulations predicted. This does not mean our understanding of the universe is wrong. Instead, it shows that the processes responsible for building galaxies and large-scale structures may be more efficient than scientists originally believed. One of the most exciting aspects of science is that every new observation tests existing ideas. When predictions and observations do not perfectly match, researchers investigate further, improve their models, and refine their understanding of nature. That is exactly what Webb is helping astronomers do today. Each new image provides another piece of an enormous puzzle that humanity has been assembling for generations. At the same time, Webb's mission extends far beyond distant galaxies. The telescope is also examining the atmospheres of planets orbiting other stars. By analyzing the tiny amounts of starlight passing through these atmospheres, scientists can identify gases such as water vapor, carbon dioxide, methane, and other molecules. These observations help researchers understand how planets form, how their environments evolve, and which worlds may possess conditions suitable for life. Every successful observation expands our knowledge while revealing entirely new questions. The deeper we investigate the universe, the more we realize how much remains unknown. Perhaps that is the greatest lesson Webb has offered. The universe is not becoming less mysterious. Instead, every discovery reveals an even larger story waiting to be explored. Galaxies are more complex than expected. Stars may have formed earlier than predicted. Supermassive black holes appear to have grown with remarkable speed. And the largest structures in existence seem to have taken shape during the universe's earliest chapters. Together, these discoveries paint a picture of a cosmos that evolved rapidly, efficiently, and on scales almost impossible to imagine. Yet despite everything humanity has learned, countless mysteries remain unanswered. What is dark matter? How did the first stars ignite? Why did galaxies mature so quickly? And are there physical processes operating in the early universe that scientists have not yet discovered? Future observations from the James Webb Space Telescope, and the next generation of observatories, may bring us closer to those answers. But history has shown that every breakthrough opens the door to even greater mysteries. Perhaps that is what makes exploration so extraordinary. Every time humanity builds a more powerful telescope, the universe responds by revealing something we never expected to find. From the atoms within our bodies to the largest structures stretching across billions of light years, everything is connected through the same cosmic history. We are not separate from the universe. We are part of its ongoing story. And as the James Webb Space Telescope continues its remarkable mission, that story is only beginning to unfold. The next discovery could once again reshape our understanding of the cosmos, and remind us that the greatest frontier is still the one above our heads.